Okay, so we already took the notes on solubility and solution. So this is going to be on solubility curves. It could also be called solubility graphs. Okay, let me see one right here. So I have two different graphs here. Okay, now the thing is, no matter what book you look in or online source you look at, they're all going to look fairly the same. Okay, on the left-hand side, it's going to say grams of solute in 100 grams of water, or possibly, what do we have here? Well, same thing, okay? It says 100 grams, solubility in 100 grams per 100 centimeters cubed of water. Here's the thing. All we're saying is we're looking at how much of stuff, all these different substances, would dissolve in 100 milliliters of water. So I know this says 100 grams, but 100 grams is the same thing as 100 milliliters because the density is 1 gram per milliliter. Okay? So you might think that these things are actually different, but 1 centimeter cubed is 1 milliliter of water, so that's 100 milliliters of water, and the same thing here. So don't think they're any different, okay? So sometimes you might get a paper where it says 100 milliliters of water, and you'd be like, what does that mean? Because this says grams, but not a big deal. And you'll notice on the bottom, this one says degree Celsius, and this one also says degree Celsius, which is pretty typical. You'll also find on these graphs that it's talking about a lot of the same compounds. So I just picked out two different ones I found online. And yeah, potassium iodide written in words, which is nice. And this is the same thing too, potassium iodide, Ki. Okay, sodium nitrate. Right? Sodium nitrate. So if we look, this one goes up to 150, this one goes up to 250 grams. So this is kind of like a closer, a more zoomed in graph. And we don't have to have all of the same things, but sometimes we do. Okay, sometimes we have the same compounds on a bunch of different graphs, depending on what you're trying to look at. Now, a lot of times in class, we're going to find ones with these, okay? And you have to actually know, right, how to put these things into words. So it won't say like Ki on the worksheet. It might say potassium iodide. And you have to know what that is. For this video, and to make it a little bit simpler, I'm going to use this graph. Okay? It's more clear, and the words are spelled out for you. So I'm going to explain a couple things about this, and then we're going to go through 6 problems, or 6 questions. They're not really problems, so it requires a little bit of thinking. Now, here's the thing. If you can do this with your finger, start here, and go whoop, and see where they meet, then you can do this. It's not that difficult, okay? So, if you think back to the notes, I mentioned something about, I'm just going to doodle some stuff on here. It has nothing to do with this graph for now. Let's say we have some unknown substance and we can dissolve 10 grams in 100 milliliters of water, okay? Let's say that's the most that we can dissolve. So the solubility would be 10 grams, okay, in 100 milliliters of water. Now, that would have to be at a certain temperature. So I'd say maybe 10 grams in 100 milliliters of water at 5 degrees Celsius. Okay? So we would have here is how much could dissolve. That's on our left side. Here's our temperature on our right side. So you can see all of these really as the temperature goes up, the solubility goes up. So as your temperature goes this way, your graphs go up, meaning you can dissolve more of this stuff in 100 milliliters of water. Okay? So let's say the maximum we could dissolve is 10. Let's say I only dissolved 5. Look back at your notes, that's called unsaturated. If I dissolve 10, and I should be able to, and that's it, that is called saturated. If I am above 10 for some unknown reason, and I mentioned ways that that could happen, that would be called supersaturated or above. Okay? So let's just pick a couple things out here. You can pick a couple pencils if you need to see where they line up. Let's just look at potassium iodide. If I were to ask you, okay, at 30 degrees, okay, that might actually be one of my problems. No, it's not. Okay, so let's say it says, well, at 30 degrees is down here, how much potassium iodide can dissolve? So all you do is you find your 30 degrees and you just go, and you see where it hits the line. Okay? If I wanted sodium nitrate, I would just go 30 degrees. Oh, it hits right there. So here we come all the way up. It touches the line right here. So then we go over and go, oh, I can dissolve 180 grams of potassium iodide at 30 degrees Celsius. Okay? If the temperature was different, I could dissolve a different amount because our graph goes up. Okay? Let's just do another one. How about this? How about at 0 degrees Celsius, which would be freezing for water, but not for potassium iodide? Okay? How much could dissolve at 0 degrees Celsius? Oh, hits right here. That would be, it's a little less than 130, so it's probably like 129, 128. You know, if I have one number and you had a different number, but we were one off, I would consider that to be the same thing. Okay? Let's do another one. Let's say, I'm just picking out things, okay? Let's say we have 80 degrees Celsius, and I want to know how much potassium nitrate, okay, dissolves at 80 degrees Celsius. Well, I find my 80. This is a little difficult, though, because it's not right on one of these dotted lines, but we can still do it. Oh, I should want to stop here? No, that's sodium nitrate. Where's potassium nitrate? Keep going, keep going, keep going, keep going. Oh, right here. So then we hit our line, and we're going to go over and see how much potassium nitrate could dissolve. Oh, 170 grams. Okay. So these numbers here refer to the amount of these things. Down here refers to the degree Celsius. Okay. So I made up a few questions on my own. All right. Wouldn't hurt to take a picture of that. I'm sure you can do that in a video. All you folks know how to do that. Screenshot it or something. Okay. And so we have a couple questions here asking how many grams. So it says how many grams basically, right? That's what the line means. How many, how much grams of sodium nitrate would dissolve at 45 degrees Celsius. I had to make a little note here because I didn't write it. If it doesn't tell you how much solvent, like water, it's being dissolved in, we can make the assumption it's going to be 100 grams, 100 milliliters, because that's what all of our graphs are in. Okay? If they gave something other than that, I mean, you could do it. It just, I don't think you would see very many problems like that. Okay? So sodium nitrate, 45 degrees Celsius. So where are we at? 45 degrees Celsius. First thing. I don't think the most important thing at first is to find your sodium nitrate. I think the most important thing is to find the 45 degrees. Okay? Because that's what we're going to have to follow up. I'm trying to look and see what's on the screen. Here, we could do that. I think we could see the problem now, maybe. Nah, not really. Okay, that's all right. So 45 degrees Celsius here, we're going to go up to sodium nitrate. Did I go past it? Nope, nope. It's right here. Okay. Sodium nitrate, if I take this over, I don't know, what's that, about 108, 109 grams. Okay, so the first one we could fill in has, I'm going to call it 108 grams. Oh, I put an extra G in there. It's okay. Now, if you have a ruler, it's not a bad idea you have a ruler. I was looking for one, but mine was broke for some reason. I was looking at for one I brought home from school. Basically, come up 45 degrees. Oh, we need sodium nitrate right here. Draw your line over. There you go. 108 or 109. Next one. 75 degrees. Sodium chloride. That's table salt. Sodium chloride. NaCl. So we're going to find our 75 over here. We're going to go up till we hit our sodium chloride. This is sodium chloride. These things kind of like meet up, but it's this kind of flattish one. Oh, it's right on the line. That's very nice. Comes over here. It's 40 grams. Next one, it says potassium iodide at 50. So how much potassium iodide could dissolve at 50 degrees Celsius? 50 degrees Celsius is here. Where's potassium iodide? That's not it. That's chlorate. It's up here. This one is. So what I say? 50 degrees. 50 degrees all the way up here, up here, up here, up here, up here, up here. Potassium iodide is right about here, 50 degrees. Come over. So we're somewhere between 210 and 220. I think we're more towards 210. So I'm going to say, what's that? 214. Okay. Halfway would be 215. We're a little short of that. 214 grams could dissolve. Okay. So here's the deal. All of these would be considered saturated. This is the maximum amount that could be held at this temperature in 100 milliliters of water. Okay. I don't think that's too difficult. All right. Basically going like this, you know, like when you do graphs and you start down here, you start over here, and you see like where they meet up. It's basically what you're doing. All right, now here's the deal for this one. It's kind of a different question. I'm telling you how much is being dissolved, and I'm telling you the temperature. Oh, it cut off. I copied these. From my on my printer. So that's 85 degrees Celsius, 30 degrees Celsius, and I believe this is 90 degrees Celsius. Okay? So the first one, let's say I dissolve 200 grams in 85 degrees Celsius of potassium nitrate. I forgot to put the nitrate. So first off, 85 here. Okay? And I'm going to go up till I see potassium nitrate. Okay? It's 85, 85, 85, 85. Right about here. Potassium nitrate. Okay? If I come over, you'll see that it's 190 grams. So I'm going to make a little note here. So actually, it could dissolve 190 grams at 85 degrees Celsius. Now, somehow, some way, I'm saying I dissolve 200. So would it be unsaturated? No. If it's unsaturated, it'd be less than 190. Saturated would be 190. Supersaturated would be above 190. So some magical, mythical, whatever, right? Something happened where we're actually dissolving more than we should have been able to. Okay, it's kind of weird setup. So maybe they increase the temperature a lot and then drop the temperature slowly down to 85, and we have this situation. Next one, 50 grams at, what do we got? Sodium nitrate. Sodium nitrate at 30 degrees Celsius. So I'm going to go find how much would make it saturated. 30 degrees Celsius, silver nitrate. 30 degrees here. Go up. Where's silver nitrate at? Why I keep saying silver? That's sodium. Look at that. You caught that mistake, I'm sure. Sodium nitrate. I keep saying silver for some reason. That is right here. Okay? If we go over, it's almost halfway, isn't it? So it's about 95. Okay? So we know that 95 grams at 30 degrees Celsius. Do you have to write these things? No, you don't. It just helps me to go, oh, okay, well, what do we got going on here? So this is the most it could hold, and we only have dissolved 50. So that'd be unsaturated, because we could dissolve more. Saturated. Don't go by my spelling. I missed the U in there. Unsaturated. Now we have 50 grams of potassium chlorate at 90 degrees Celsius. Potassium chlorate's this one down here. 90 degrees Celsius is right here. Hits right here. We go over 50 grams. Look at that. 50 grams, right? It's like right on the line. Somebody will probably tell me, well, it's a little bit below the line, actually. I think it's right on the line. So from our graph, it says 50 grams at 90 degrees Celsius. And then I'm telling you in the problem that in the lab or wherever, I dissolve 50 grams of this in 90. So 50 and 50, that would actually be saturated. Okay. Now here's the deal. They'll ask you, if depending on the sheet that you get or whatever you look at online, all these questions. But really it just comes down to this basic idea. Find the temperature, go up, find how much can dissolve and write it. Or if it's telling you, hey, we dissolve this amount, is it saturated, unsaturated, supersaturated, still find out how much it would be at that temperature and then determine, oh, you have less than that? Unsaturated. You have the same amount? Saturated. Oh, you dissolve more somehow? It would be supersaturated. So I think they look crazy, you know, but they're not that bad. And like I said, I think it's a lot easier to look at the ones with the actual names than to look at the ones with the chemical formulas written out with the symbols. But, you know, at this point, you should know what those are anyway. All right? So those are examples.